Hi everyone, this is Babaiah, Assistant Professor of ECE Department, MLR Hyderabad. Today I am going to explain about derive the some time domain specification expressions. In previous section, we learned what are the definitions of the time domain specifications, right? Today class, we are going to derive some time domain specifications. Now let's move on to today overview. Just here observe, derive the expressions of the time domain specifications. The first one is the rise time expression, and next is the peak time. Now we are going to derive these two expressions of the time domain specifications from the underdamped second order system. For underdamped second order system response, when we are going to apply the input step, from that we are going to derive the expressions of the time domain specifications of today class, right? Now move to the and moving to here, first we need to derive the rise time here. Derive the expression of rise time here, right? So what is mean by rise time? In previous class I explained the each and every definition of time domain specification. Rise time is nothing but here what, just here observe in this graph, just see, this is the t suffix r, that is the rise time here. See, observe 0 to 1%, or else the time taken for the response to rise from 0 to 100% of its final value is known as the rise time, right? Simply. So here rise time, or it can be represented as t suffix r, the unit step response of second order system. For underdamped case, I am going to consider the response, that is c of t equals to 1 minus e power of minus zeta omega n t divided by under root 1 minus zeta square sine omega dt plus theta. Sine omega dt plus theta. Here in place of here, what is, I am going to consider t equals to tr, right? T equals to tr, and also at c of t is equals to c of tr, that is equals to value 1, right? So that is equals to value is 1. So here see, observe, at t equals to tr and c of t equals to c of tr equals to 1, equals to 1. So here 1 minus e power of minus zeta omega n t divided by under root 1 minus zeta square sine omega dt plus theta. Here we are going to consider the in place of t equals to tr. T equals to tr, just write here. In place of t, I am going to write the t, or c of tr equals to 1 minus e power of minus zeta omega n t suffix r. Here this one is the t suffix r under root 1 minus zeta square sine of omega d tr plus theta equating to 1. Because of here from the graph, just we observe c of t or c of tr, that is equals to what, 1. So that is equals to 1. So now I am going to equating to 1 here. So here from this, see, observe c of tr equals to 1. So 1 minus this term and equating to 1. So now I am going to, this term is moving to the right side and this term is left side. So 1 minus 1 is 0 and this term is e power of minus, this term minus, so it is came to here. So that is positive term. So e power of minus zeta omega n t, e power of, or else directly I am going to here consider, so e power of minus zeta omega n tr divided by under root 1 minus zeta square into sine of omega d tr plus theta equating to 0, right? So here observe since this term is exponential, now I am going to, this denominator part is moved to here, 0 into something is, it is going to be 0, and e power of minus zeta omega n tr into sine of omega d tr plus theta, that is equals to 0. So here it is, this term I am going to consider as not equals to 0. See here, since e power of minus zeta omega n tr, that is not equals to 0, then that this term I am going to consider sine of omega d tr plus theta equating to 0, this term. See here, observe. Okay, next here, when I am going to consider here in place of t term or sine of some value, just I am going to, when theta or phi equals to 0 or pi, 2 pi, 3 pi, and so on, where omega d tr plus theta equals to 0, so sine up, I am going to just consider here sine phi is nothing but what, sine phi equals to 0, right? Sine phi equals to 0, that is equals to sine phi 0 or sine 0 0, sine 2 phi 0, sine or phi value consider as 0, phi, 2 phi, 3 phi, both we are going to get the same value. So same value. Now I am going to consider just sine phi equals to, so sine phi equals to 0 or sine phi equals to 5 or sine phi equals to 2 phi, sine phi equals to 3 phi, just I am going to consider here sine phi equals to 5, I am going to consider sine phi equals to 5, just I am going to consider, so or sine phi equals to 0. See here up, so see, just I am going to phi equals to consider as 0 and phi equals to 5, so I am going to consider sine phi equals to 0, so sine phi equating to 0, consider, so in place of 0 sine phi, if phi equals to 5, I am going to consider, so sine phi equals to 0, in place of 0 I am going to write the sine phi, that is, so here what is this term is directly going to sine of omega d tr plus theta equals to, in sine phi I am going to consider, here sine and sine both are get cancelled, so omega d tr plus theta equals to phi, right? So here omega d tr equals to phi minus theta, where tr is nothing but the rise time, so rise time tr equals to phi minus theta by omega d, simple. Okay na, omega d, this is the rise time. Here just observe, this one is solved equation. Omega d tr plus theta equals to phi, because of sine phi equals to 0, in place of I am going to consider sine both cancel, phi equals to omega t per. So this is I am getting rise time equals to tr equals phi minus theta by omega d, where omega d is nothing but what, damped frequency oscillation. See here, observe, from and constructing the right angle triangle zeta and under root 1 minus zeta square. See, observe, for the theta purpose here I am going to consider the theta here angle, so this angle adjacent value is under root adjacent is zeta square and opposite is under root 1 minus zeta square, adjacent, opposite, hypotenuse. So each and from this, just here observe, sin square theta plus cos square theta is equals to 1, right? Sin square theta plus cos square theta equals to 1. Here sin square is nothing but what, sin is nothing but what, here opposite by hypotenuse, this one square root get cancelled, next cos square, this one adjacent, so 1 minus zeta square plus zeta, 1 minus zeta square, see here zeta and square is zeta square, so value I am going to get the 1, So this is the correct. Sin square theta plus cos square theta is equals to 1. So we are going to consider this one here. From this, observe sin theta divided by cos theta. Sin is nothing but here under root 1 minus theta square, and cos is zeta. So under root 1 minus zeta square divided by zeta. This is the tan theta from this right angle triangle with zeta and under root 1 minus zeta square. Just we are going to get the tan theta value. Here theta is nothing but what? Here from this theta equals to what? Tan inverse under root 1 minus zeta square divided by zeta, simply. So that is the theta value. Here see, observe next. Here theta equals to tan inverse under root 1 minus zeta square by zeta. The damped frequency oscillation omega d equals to omega n into under root 1 minus zeta square. Just substitute all these two in rise time equation. Tr equals to 5 minus theta. In place of theta, tan inverse under root 1 minus zeta square by zeta, and divided by omega d. Omega d damped frequency oscillation omega n under root 1 minus zeta square. Okay, radians per second. This is the radians per second. So here omega n under root this value, and theta or tan inverse of under root 1 minus zeta square by zeta should be measured in radians only. Should be measured, or theta measured in the radians. Measured in radians only, right? This is the rise time expression. So rise time Tr equals to 5 minus under root 1 minus zeta square divided by zeta divided by under root omega n into under root 1 minus zeta square. Simply tan inverse 1 minus zeta square divided by zeta divided by divided by omega n into under root 1 minus zeta square. So this is about the rise time. Very important formula. Okay, these are the very important for gate also, right? Next, coming to the derive the expression of the peak time. Here peak time t suffix p. See here, observe, peak time is nothing but here the maximum peak value or time taken to reach the response to maximum peak value or final value, right? Maximum peak value or maximum peak overshoot or maximum peak value, that is nothing but the peak time. Here see, to find the expression for the peak time tp, for differentiating for the expression of peak time, we are going to just differentiating the response, that is the c of t, differentiating that c of t and with respect to t and equating to 0. See here, differentiating the c of t with respect to t and equating to 0 for any peak value. So peak of this response, we need to just calculate the differentiating that peak value, or differentiating that peak differentiating that signal, differentiating that response, then only we will get the peak value of that response, simply. So differentiating that output is c of t and equating to 0, then we will get the peak value of that response, right? Here see, that is I'm going to write here d by dt of, here d by dt of c of t at t equals to tp, because of tp peak time, so that is equating to 0. The unit step response of underdamped second order system is given by, the unit step response of underdamped second order system is given by c of t equals to 1 minus e power of minus zeta omega t by under root 1 minus zeta square sin omega dt plus theta. You should remember this one. This is the response of the underdamped second order system. This figure, this is the response or graph of the underdamped second order system for unit step input from this peak time. So peak time, here observe, this is tp is nothing but here c suffix tp. Now This is a very important equation. C of t equals to 1 minus e power of minus zeta omega nt divided by under root 1 minus zeta square sine of omega dt plus theta, omega dt plus theta. Next here, now differentiating and equating that equation. So this is our equation. Now differentiating the c of t with respect to t. See here, d by dt of c of t, d by dt of c of t, this one, and here one, just I am going to here differentiating of 1 is equals to 0. So 1 equals to differentiating, that is 0, and minus these two terms. Just observe, this is one, this one, these two are uv form, right? Uv form. So u into v derivative minus v into u derivative. Here uv form, so directly I am going to consider this u into v derivative, right? Or UV form, anything. So you should just write u into v derivative, so v into u derivative plus or u into v derivative or v into u derivative, any terms. So d by dt uv form u into dv by dt plus v into du by dt. Just you can use this formula. By using this formula, just here first one is 0 for 1, d by dt of 0 is nothing but, or 1 is nothing but 0. So 0 minus something, so these two terms only available. So for the two terms uv form, just here e power of minus zeta omega nt divided by under root 1 minus zeta square, this one. As it is, I am going to consider sine omega dt plus theta. Here I am going to consider the u equals to sine omega dt plus theta, and v equals to e power of minus zeta omega nt divided by under root 1 minus zeta square. So here u as it is, I am writing v e power of x derivation, differentiating, that is e power of x only. After that, here in x place minus zeta omega nt, there minus zeta omega nt, again differentiating this term, t is get cancelled, so minus zeta omega n, so minus zeta omega n. Okay, this is minus zeta omega n sine of omega dt plus theta, so same as, plus this term again as it is, I am going to write this v here, and u derivative here u sine theta, so sine derivative is cos theta, so cos theta, so theta in plus omega dt plus theta is there. Next again in this term, just sine theta is cos theta, in place of theta we have a one t term is there, so t is there. So now again derivative, this t term is theta is 0, so omega dt, t is 1, so omega d into omega d we get. So this is the differentiating the equation form. Next I am going to consider here omega t is d is there, omega d is nothing but damped frequency oscillation. We know that omega d equals to omega n into under root 1 minus zeta square, under root 1 minus zeta square. See here, omega d equals to omega n under root 1 minus zeta square. Just substitute in omega d. D by dt of c of t is equals to e power of minus zeta omega n t, and here one more thing, here my negative is there, negative, so both are just minus zeta minus plus, and e power of minus zeta omega n t by under root 1 minus zeta square and zeta omega n sine of omega dt plus theta, same as it is. And here see, this is negative term, so minus omega n, omega d is nothing but here omega n into under root 1 minus zeta square, in place of omega d just I am going to write, and denominator under root 1 minus zeta square, this term is directly I am right here, so e power of minus zeta omega n cos of omega dt plus theta. Now let's see, here e power of minus zeta omega n t, all these terms are available. Okay, good. just common this term e power of minus zeta omega n t, e power of minus zeta omega n t, and divided by under root 1 minus square, divided by under root 1 minus square. Okay, and one more term is there, omega n is here also there, omega n is there, omega n there, omega n there. This term is common and this term is common. So just common, omega n e power of minus zeta omega n t by under root 1 minus zeta square, just common. Here zeta is there, sin omega dt plus zeta is there. Next to minus as it is. Here under root 1 minus zeta square is cos omega dt plus zeta also there. Right? Up to here clear, right? Next here, see, observe. E power of minus zeta omega n t and under root 1 minus zeta square. So here just I am writing here omega n is there. By construct, see here zeta is there, under root 1 minus zeta square, sin theta is there, cos theta is there. Just we need to arrange this form into sin a cos b plus cos a sin b cos a sin b, that is equals to sin of a plus b. Now we are going to arranging these terms into the sin a cos b plus cos a sin b. For that or sin a cos b minus cos a sin b. Anyone here place is there. So minus, if you are going to write the minus sin a cos b minus cos a sin b equals to sin of a minus b, sin of a minus b. Any, so here negative is there, so negative formula you can use, sin of a minus b. So for that as it is, I am going to write omega n divided by under root 1 minus zeta square e power of minus zeta omega n t, and here by constructing right angle with zeta and under root 1 minus zeta square. See here, see, on constructing right angle triangle with zeta and under root 1 minus zeta square, we get sin theta equals to under root 1 minus zeta square, where theta opposite side is under root 1 minus zeta square divided by hypotenuse. So under root 1 minus zeta square divided by 1 is nothing but sin theta. So this one, cos theta is nothing but adjacent by hypotenuse. So adjacent is nothing but zeta here, zeta by 1 is zeta only. So sin theta is this term under root 1 minus zeta square, cos is zeta, right? So now these two terms we are going to substitute in place of here. See, observe, sin theta equals to what? Sin theta equals to under root 1 minus zeta square, and cos theta equals to what? Zeta, right? In place of, just you should write sin theta 1 minus zeta square under root 1 minus zeta square, substitute. Here zeta is there, that is nothing but cos theta. Okay, writing. So under root 1 minus zeta square is there, sin theta just write. Okay, now see, observe, sin a cos b minus cos a sin b. So that is nothing but sin a minus sin of a minus b, simply. So here e power of minus zeta omega, same as this I am going to write here, sin omega dt plus theta, this term first and this term next, sin a cos b minus cos a and sin b. This is in terms of sin of a minus b, right? So now I am going to write directly sin of a minus b. So here sin of a is nothing but here omega dt plus theta minus theta, sin a minus b. Here a is there, b, so a minus b, that is nothing but theta get cancelled, omega dt simply. So sin of omega dt we are going to get, right, where t equals to tp, maximum peak. So d by dt, c suffix t equals to 0, right? So here no, sin of omega dt in place of t equals to tp, peak time, just write that one. Same as it is here, omega n divided by under root 1 minus zeta square e power of minus zeta omega in place of t, Tp sine of omega d Tp completed equating to 0, because of for any signal peak value is calculated by differentiating that maximum value or peak or maximum, or else the just differentiating that response of that signal, we will get the peak value of that response or that signal. So for that, this one is, so here, since e power of minus zeta omega and Tp not equals to 0, or it is exponential term, so it is not equating to 0, I am considering here. Next term is sine of omega dTp equals to 0, so 0 is there, so sine phi equals to 0, I am going to, in place of phi equals to 0 or phi or 2 phi or 3 phi, I am going to just grab sine 180 degrees 0, sine 360 degrees 0, 3 phi, sine 0 is 0, so like that. So I am going to consider here sine omega dTp equals to 0, for that in place of 0 sine of phi, sine phi, so sine and sine, here see, observe, sine omega dTp equals to sine phi, so sine get cancel, omega dTp equals to phi, like that, sine omega dTp equals to phi, we are going to get here. Tp is nothing but the peak time, right? So peak time Tp equals to phi by omega d, this is the formula, phi by omega d, where omega d is nothing but the damped frequency oscillation, that is omega d equals to omega n into under root 1 minus zeta square, damped frequency oscillation, that is radians per second, omega n under root 1 minus zeta square. So peak time equals to Tp equals to phi divided by, in place of omega d, omega n into under root 1 minus zeta square. Simply, this is the derived the, or else this is the expression of the peak time as well as the rise time, right? These two are here, see, observe, this is the peak time by using constructing rectangular or right angle triangle, just we consider, or we are construct the zeta and under root 1 minus zeta square, from that sin theta cos theta values just to substitute, and for every signal peak value is just calculated by the differentiating that signal response, then only we will get the, and after that, that is equating to 0, then we will get the response or that peak value or peak time, right? This is the way of derive the expressions of time domain specification from the underdamped second order system, just we consider, from that we are going to calculate, or we are already determined the peak time as well as the rise time. For the next expressions for the maximum overshoot or settling time, for that we are going to discuss for the next class. I hope you understand today to derive the expressions of rise time as well as peak time. I hope you understood. Thank you all.